Hi, this is Mr. Max with Sankofa Mathematics. So this is paper 1, AS level 2023. Right. This is first question. The equation of a curve is equal to y equals to 2x squared minus x minus 3x. Now they are asking you to find the set of values of x, which means your answer will be a range. Inequalities are going to come into play. So they are saying that the 2x squared minus x minus 3 should be greater than negative 2. So essentially, this leads to quadratic inequality. Okay, bringing that negative 2 over, adding 2 on both sides is going to give you negative 1 greater than 0. So what essentially this is implying is that the whole of this function is greater than 0, the whole of it. That means the function, as it's going to open up like so, because the value of a is greater than 0, this a specifically. So what that requires, saying that the function is greater than 0, the function is above the x-axis. This is the x-axis. So the values that we are looking for is going to be this range. So whatever, let's suppose I say this is A and that is B. One of the solutions is going to be A is less than, or rather let's say we start with X. One of the solutions will be X is whatever the X value is going to be less than that value of A, which is what I'm going to calculate. Or one of the solution will be X is greater than whatever B is. So that is what we are expecting to get as an outcome. So I'll call these ones the critical values. So in order for me to find the critical values of A and B, I'm going to let this 2x squared minus x minus 1 be an equation that I should be able to solve. All right, and this is obviously going to factorize. So you have got x, 2x, and then x minus 1 plus, okay, this just looks a little bit, yeah, now I think it's better, plus 1, and then also x minus 1. Everything equals to 0, so you have 2x plus 1 in its own bracket, and then the common bracket of x minus 1. Right, so this is going to assist us in order for us to calculate the unknowns. So you're just going to let each bracket is equal to 0, okay? Then you can actually find the values of A. In this case, x is going to be negative 1/2, okay? Subtracting 1 and then dividing by 2, or x is going to actually equal 1. But again, as I was saying, we are not solving equations. These are going to be inequalities. Right, so the solutions therefore that we were looking for, x is going to be less than negative 1/2, or x will be greater than 1. These are the solutions that we were expecting when I had created that, or critical values, when I spoke about the critical values over there. Then there is a B part to the question that says that show that the equation px squared plus 3px plus 2p is equal to 2x squared minus x minus 3, so that has distinct roots, real roots for values of p, and then p should not equal to negative 5. Okay, right. So if you were to look at what we expect to get, this is the determinant, which is b squared minus 4ac. This should be greater, oh no, has real roots. Yeah, it should be greater than 0. It's one of the concepts that we are going to show, okay? And this is a question with 4 marks. Right, so I'm going to take the two equations as we equate them to each other. And I have px squared plus 3px plus 2p is equal to 2x squared minus x minus 3. That is going to leave me that p minus, can rearrange, so I'm going to get all the terms that contain the x squares. So I'm going to take this over here with this one. Of course, I'm going to move the 2x squared to the left, so it's going to be minus 2. But I'm just going to keep the x squared term on the outside, okay? And then I'm going to do the same for the term that contains the coefficients of x, so that is going to be 3p. And then when you bring this one, you have a negative 1, which becomes a plus 1 if you have to sort of move it over the equal sign, if you can literally say that. And then the one that is now left is for me to consider the constants, which in this case, the constant terms are just 2p plus 3. Now all of this, okay, I'm going to let that be equal to the discriminant. Right, so it says take b squared, or b is 3p plus 1. We square that, minus 4 times the value of a, which is p minus 2, times the value of c, which is 2p plus 3. Okay, we're going to see what that is going to give us. So there's a little bit of manipulation here. So this is 9p squared. By this time, you should be very familiar on how to multiply binomials. That's what that's going to give you. And over here, you have to be totally a bit careful as to how you are going to multiply out this. All right, so I'm going to introduce a square bracket so that I can multiply this 4, and then I have p minus 2, 2p plus 3. So I'm going to deal with that bracket first. So this still stays 9p squared plus 6p plus 1. And then you have got 4p minus 8. So I'm just going to multiply first bracket by that 4. Okay, this is something you need to be very careful, because the chances of you making a mistake is very high. So this leaves us with 9p squared plus 6p plus 1 minus, when you multiply out, this is going to be 8p squared. When you multiply 4p times 3, that's 12p. When you multiply this one, you're going to get a negative 16p. And then obviously when you multiply negative 8 times 3, that's negative 24. Now, of course, you need to know that this negative is going to sort of multiply with each term inside there, right? But before we do that, I'm just going to sort of simplify the 12p minus 16p, and that is minus 4p, and a negative. Okay, this one we're just going to leave it as minus 24. Now I guess I am ready to multiply out with the negative there. So it's 9p squared plus 6p plus 1 minus 8p squared. Double negatives is a positive 4p. Double negatives is a positive 24. That is equal to the discriminant, which is what we're going to look for. 9p squared minus that is just going to be p squared. 6p plus that is going to be 10p. And 1 plus 24, it is 25. If you were to factorize this is a perfect square trinomial because half of 10 is 5 and 5 squared gives you 25. So this is going to be p plus 5 all squared. Now there is something really important here. They said that the value of p should not equal to -5, because if you put p to be -5, this is going to be 0 if you put p -5 in here. Since that condition was made clear to us, we then will know that the discriminant here, this value is going to be greater than 0. And when it's greater than 0, as p should not equal to -5 as a condition that we were given. So whenever the discriminant is going to be greater than 0, we would know that the discriminant is, first of all, it's a perfect square, okay, because that's what this is, a perfect square trinomial. It is a perfect square, okay, for any value of p that you insert, for any value of p except for p equals to -5. So that is what they required, that we have to see what that this is going to have two, or has going to have distinct real answers. Okay, good. That takes me to question 2. It deals with a bit of functions. I have got function f and function g are given by f of x, which is equal to 4 upon 5 minus 2x, and then they say x should not equal to 5 over 2. Once again, that condition would make that denominator 0, hence x equals to 5 over 2 is not considered. This is also going to be a discontinuous curve if you have to sketch it, because you will have an asymptote at that line while x equals to 5 over 2 or 2.5. Then g of x is equal to 3x plus a, and x is an element of all real numbers where a is given as a constant. So first thing is we're supposed to find the inverse of f. And to do that, I'm just going to write f of x as y equals to, and that is 4 over 5 minus 2x. And then I'm going to switch the variables around. Then I am using this technique so that I can make y the subject of the formula. Right, so I'm just going to keep multiplying throughout, sort of cross multiply if you look at it in that kind of context. All right, 5, the whole quantity of 5 minus 2y, multiply that with x, and you can obviously divide or multiply out by x, but another way of doing it is perhaps just to divide here by x and also there by x. This leaves me with 5 minus 2y on this side is equal to 4 over x. All right. Don't particularly like that negative 2y to be on that side, so I'm going to have 5 minus 4 over x is equal to positive 2y. And then whatever this answer is over here, this whole answer, I'm going to divide it by 2. Dividing by 2 is the same as multiplying by a half, so y is equal to 1 over 2 and then 5 minus 4x. Okay, right, so we can just sort of distribute that over. Then y is equal to 5 over 2 minus, and then you have got 4 over 2x. 4 over 2x, if you were to clean that up, then we're supposed to find the inverse. So now we're going to use the inverse notation, which is 5 over 2 or 2.5, totally up to you how you want to write it, minus 2 over x. This is also 1. You can find equivalent values like 5x minus 2, or minus 4, rather, minus 4 all over the common denominator of 2x, if you wish to write it in that way. Any one of them will do, because we're just supposed to find the inverse of that function. Then they ask you what is the domain of this function. Now it's very clear. It's anything, however, there is a condition because you have a denominator there. So x should not equal to 0, because the fact the matter is that if x is equal to 0, this is not going to be possible. So the domain then, you can write it as this notation is x such that x is not equal to 0. So that is going to be the domain. Then they say find an expression. All right, so it's compound. So let's just see what was f of x again. F of x was 4 all over 5 minus 2x, and then g of x was equal to 3x, is it, plus a. Okay, all of this can be found if you go check right there on top. Okay, so they say we are supposed to find, so this is Roman 1, so Roman 2 most probably will want us to, okay, they will probably give us some value, and then we'll have to calculate maybe the value of a. But here they say we must leave our answer in terms of a and x. Right, so what does this imply? So we are going to take all of the function f, and we're going to put it into function g. So all of function f, all of this is going to be replaced everywhere you have an x in the second function. So this gives you that g of f of x is going to equal to 3 times all of this, which is 4 over 5 minus 2x, plus a. Okay, just to make sure that you do get the understanding of that. Right. What is left is just for us to just quickly simplify. 3 times 4, that is 12, all over 5 minus 2x plus the value of a. And that is pretty much all that we can do at this stage for this question, Roman 1. So that is the solution. Okay, then now they are saying we are now supposed to find the value of a when g of f is g of f, or gf of 3 is equal to that. So what that means is that when you take our composite function on top, which was 12 upon 5 minus 2, and now the value of a of x is going to be 3, this should equal to negative 4a plus 13. All right, so what you have on the left hand side is just going to give you a number that we can actually calculate. You have got 12 divided by 5 minus 6, which is going to leave this as negative 12 over here. Okay, if you look closely. All right, so there was this plus a that I just forgot to write down. So I'm just going to write down that plus a from what we have over here. So plus a, okay, right, just to make sure that we don't make those mistakes. So from here, this becomes pretty much straightforward on how to calculate the value of a. So this is going to be negative 12 minus 13 is equal to negative 4a minus a. Totally up to you. I could have decided to add a's on both sides to that side and have a positive value. All right, so let's rather do that. Have the a's to the left and the numbers to the right hand side. So that is going to give you a plus 4a is equal to 13 plus 12. I think it just looks a little bit better for us to solve. This is going to give you 5a is equal to 25, and then eventually a will be 5 into 25, which is equal to 5. All right, good. Now let's look at question 3. So question 3 deals with partial fractions. Bear with me. Okay, let's see if it's going to restore our work, and we continue. Right. It deals with partial fractions. So what you're going to do is, there are many ways you can do this, obviously, but for this, really straightforward, you look at those denominators. So I'm just going to take my values of, so sort of think of these two fractions and make them one fraction. That's going to be A will need x plus 2, and then B will need x minus 4. Obviously, it's going to be all over x plus 2, and then what? And x minus 4. This is identical to minus 2x plus 26 over the same x minus 4 and x plus 2. Right, you can actually go ahead and drop those, drop these denominators and only equate the numerators. So I'll have A, and I have an x plus 2 here, plus B, and I have an x minus 4. And let's say this is equal to minus 2x plus 26. Okay, so on this side, I'm just going to multiply out. This is giving me ax plus 2a plus bx minus 4b is equal to negative 2x plus 26. So I'm just going to get all the terms containing the coefficient of x. This is a plus b, okay, of x is negative 2x. And then the coefficients of the constant term is 2a minus 4b is equal to 26. So you don't really need to write that down. So at the end of the day, let's just say this is the equation a plus b is equal to negative 2. And this equation, I'm just going to clean it up by dividing this equation by 2 over here and 2 over here and 2 over here. So that equation becomes, it becomes a minus 2b is equal to 13. So we're going to solve these two equations simultaneously. This could be my equation 2, or let's just rather say this is equation B and this is equation A. All right, might looks a bit sketchy if I use the same sort of letters, but this is my first equation, so, and this is my second equation. So this is my first equation and this is my second equation. So I'm going to solve them simultaneously by subtracting. So I'm going to have a minus 2b equals to 13, and I'm going to have the other equation, which is a plus 2b equals to negative 2. And we're going to solve them simultaneously by subtracting, because the coefficients of a are exactly the same. If you subtract, then the a's cancel eventually. This one and that one cancel. And what we're left is negative 2b minus 2b. That gives you I don't know where this 2 is coming in. There's no 2 in this one. Okay, so it's really wondering what's going on. All right, let's see where we're at with negative 2 minus 1. That is over here. That is obviously negative 3b. Now if 13 minus negative 2, that is going to give you an answer of 15. And then b will be 15 divided by negative 3. The value of b is negative 5. Now, I'm going to use this equation 1, and that's equation 2. I'm going to use equation 1 to find my value of a. And from equation 1, we are seeing that a plus my b, which I now know as negative 5, should give me negative 2 as an answer. Of course, this becomes a minus 5b, minus 5, minus 5b, minus 5, okay, then eventually the value of a would be negative 2, add 5, and that is the same as 5 minus 2, which gives you 3. Eventually my answer is therefore a equals to 3 and b equals to negative 5. Right. It's a little bit of work, but it is straightforward in all honesty. Let's look at question 4. It says, find the first 3 terms in the expansion of 3 plus ax to the power 4 in ascending powers of x. Okay, so the first term is, that's what I like to do. I like to create 3 brackets. The second term, I'm going to create 3 brackets again. And then the third term, I'm going to have my 3 brackets. And I hope you understand from your formula that we are going to have, that is 4, so this is 4, 0, 4, 1, and 4, 2. This is the value of a, which happens to remain 3, 3, and 3. This is the value of b, so I'm talking about the a plus b to the power n. That's what I'm referring to, okay? So the value of b happens to be ax, ax, and ax. Right. Another thing noting that whatever you have here should correspond with this one. So that's going to be 1, correspond with that one, and that's going to be 2. And this plus this should add to this number on top. So that's 1, so this one becomes 3. That's 2, so this one becomes 2. So all of these are values that can be calculated. 4 choose 0 is 4. I mean, it's 1. You can use your calculator to check that. 3 to the power 4 is 81. And then ax raised to the power of 0 is just 1. When you do this, you multiply out here, you're going to get this 27 times 4, okay, which is 108. Of course, you're going to have 108 ax. When you do this one, so again, if you have a problem, you say 4 choose 2, okay, times, this is 9, times 9. So what is that going to be? That is 54, okay. So that is 54, and a square, x square. So do my 3 terms then. My 3 terms are 81, all of them are positive, plus 108a, plus 54a square x square. Right. Now, they are now saying the coefficient of x squared in this expansion is 1080. So what I'm going to do is I'm just going to write 1 plus 4x, and this expansion over here, I'm going to write the first 3 terms that we just did in part A of our question. Okay, like so, because we are now going to look for the possible values of a. So let's use these 2 to see in which scenario are we going to get an x squared term. It's this 1 times, obviously, the 54a square x square. This one is going to give you, if you multiply, it gives you 54a square x square. And another condition is going to be, if you multiply this 4x, this 4x, is it? Yeah, I think we left out, it's one of those days. There should be an x here. Let's just go back and see. Yes, it is there. We left out an x here. We left out an x. Right, so now I have got this 4x over here. If you multiply it with 1 408ax, you're going to get an x square scenario here. Okay, that is going to be 432a x squared. That's what I was looking at. Right, so what does the question say? The coefficient of x squared. So I'm just going to write those coefficients. It is 54a squared plus 432a. Okay, this should equal to 1080a. It says find the possible values of a. So please, I'm not going to is it 1080? Just 1080 is equal to 1080. Yes, equals to 1080. Right, this can actually be simplified a little bit. If you were to divide by 54, that means this can be divided by 54 and this can be divided by 54. The same with this one. This is going to leave you with a square, and then we take 432 and we divide that by 54. What do we get? We get 8, so that's plus 8a. And then let's just say this answer is equal to 1080. Let's divide that as well by 54. We're going to get 20. Right, so at the end of the day, I have a squared plus 8a minus 20 is equal to 0. Then this should factorize, and this factorize to a. Of course, the bracket 1 will be positive, 1 will be negative, and it's the positive 10 and negative 2. That's the conditions. A equals to negative 10 or a equals to 2. And those are the possible solutions. Now, those are the solutions of A that they required us to calculate. Okay, so the reason why you see that you had to find those three terms in the first instance is that you are given another binomial and you are supposed to see what do you multiply with. So if I multiply this one times this, that is going to give me what I have over here. That's a term that is square. If I multiply similarly this 4x with this one over here, then that is going to give me what I have over here. Okay, then you're told that the coefficients of x squared is this, so that's why I don't have to write the x squares, but just anything that contains them in terms of their coefficient. 54a squared plus 432a is equal to 1080, and then you take it from there. Okay, right, then we come to question 5. The nth term of a sequence is given. Now this sequence is a geometric sequence, as they obviously tell us here, and we are supposed to show that this is a geometric sequence. One way that you can do this is by looking at what is going to be the first term. So the first term is going to be 3m minus 4, and here I'm going to put 1 here. 1 plus 1, so that take that to 2. The second term is going to be 3m minus 4. If you put a 2 there, you're going to get a 3. And the third term is going to be 3. Then you have m minus 4. So you have got the 3 there plus 1. That is obviously making that a 5. Then you can see clearly that there is a common ratio. If you were to divide term 2 by term 1, okay, if you divide term 2 by term 1, you take term 3 divided by term 2, you would get a common ratio of m minus 4. That is enough for me to justify that you have a geometric sequence. Right, they now say determine the range of the geometric sequence. So what do we have? We know that the first term, which we're going to represent by the letter A, is 3m minus 4 squared. What else do we know? We also know that r is equal to m minus 4. I'm just writing down the stuff that I need. Now, I don't really need to know the value of a. What I need to understand is that when dealing with geometric progressions or sequences, when a common ratio, I'm just going to write it down so you can just take note of it. When a common ratio is between -1 and 1, okay, that is like the common ratio, like this, the terms become smaller and smaller, and they become smaller, right? Smaller in size, and we call such a sequence a convergent sum. It converges to a number. Okay, it converges to a number. So for us to be able to determine that, because you have got determine the range of values of m for which this series converges, that is what I'm using, right? Maybe I can just add that there so you can also take note. We call the sum of such, hope my handwriting is not the problem, such a geometric sequence, a convergent sum. So having said that, I'm going to then use this concept over here with my r. That's what I'm going to do. So I'm going to say r, which I can actually just take the m, minus 4 should be between 1 and -1. That's it. All right. So from here is to have m alone. Then you will have m. So what you are going to do is you are going to add 4 here and add 4 here. That's how you get rid of that. So at the end of the day, you are now left with 1 plus 4, which is 5, 4 minus 1, which is 3. And that is the solution. Okay? They are asking what are the ranges of m for which this is going to be. Now, m in itself there will be a number that is between 3 and 5. Okay? Because if it's 3 here, this becomes -1. If it's 5 here, this becomes 1. That's what we are looking for. All right? Good. Then there's a C part to the question. Find the values of m correct to 3 significant figures for which the sum to infinity is equal to -1. The sum to infinity, which is always a over 1 minus r. In this case, they say it is, the sum to infinity is 1. What do we know from before? We know that our a was given to us as 3 in brackets m minus 4 all squared. Just make sure if you can still remember that. Yeah, I wrote it here as well. There's the first term. What do I also know? We also know that r was given as m minus 4. So I'm going to use that. Value of a, which is 3 in brackets m minus 4 squared, over 1 minus the value of r, which is m minus 4, and this should equal to 1. Then they also say we should give our answers to 3 significant figures, which most imply that this becomes something like a quadratic equation, and then I have to use the quadratic equation formula in order for me to find the missing values. Very important that you take that into account. Right, I'm just going to, because of space, I'm just going to continue just to simplify the denominator a little bit more. You have got 1 minus 4, 1 minus -4, that's going to be 5. So that is 5 minus m, and this is equal to 1. Right, So you can actually see that I will now do cross multiplication. So I will have 3m. I'll have 3m minus 4 squared is equal to 5 minus m if you multiply that. So this becomes 3. Then you have m squared minus 4m minus 4m is minus 8m plus 16 is equal to 5. I can actually bring that 5m to save again space minus 5 plus m, then everything is equal to 0. Distributing that 3, this is going to be 3m squared, 3 times 8 is minus 24m, 3 times 16, that's plus 48 minus 5 plus m is equal to 0. This becomes 3m squared. You have got minus 24 minus 5, minus 24 minus 5. No, minus 24 plus 1. That is the coefficients there. It's going to be minus 23m. Then 48 is just going to be 48 minus 5. That is going to be plus 43 is equal to 0. Right, we can actually straightforward use our quadratic equation formula. So what I like to do my b squared minus 4ac apart. You can straight up punch them into your quadratic equation formula. So I know that b is minus 23, minus 23. I'm going to square that, minus 4, the a is 3, and c is 43. If I were to do this on the calculator, it gives me the square root of 13. Right, from the quadratic equation formula, I know that the quadratic equation formula, which is given to you, in this case we're looking for m, so it is m equals to minus b plus or minus, right? In this case, I will just say my discriminant, okay, which is what I got, over 2a. So in this case, I will have m is equal to, you're going to have a negative because the value of b is negative, so that's going to be 23 plus or minus the square root of 13, and everything will be over 2 times 3, which is the value of a over there. Right, so m equals 23, let's take it when it's positive, over 6, or m equals 23 when it's negative over 6. You can just punch that stuff into your calculator and then you can find. And I'm going to find the values of m and I'm going to leave them to 3 significant figures. One will be 4.43, or the other one is going to be 3.23 respectively. And both these answers are given to 3SF as required in the question, and I highlight that, very important. Okay, this brings me to question 6. The diagram shows a major arc AB of a circle with a center O and a radius of 6 centimeters. The line AB, okay, is a tangent at E, very important, to the arc CED, to this arc, and then of a smaller circle, center O, and angle COD is 1.8 radians, as you can see. They say show that the radius of arc CED is that 3.73, 2 significant figures. The radius of CED. Now, the radius of CED, which is this distance here, up to that distance there, it will be the same. It will be the same as from here up to there. That is going to be the same thing. All of them are just radar. And that is what I'm actually more interested in. I'm interested in a triangle that goes, let's use a solid line. I'm interested in this triangle that I'm seeing over here. I'm seeing a triangle like so. Well, it doesn't really look the way I want it. Perhaps. Right, that's what I'm seeing. So I'm seeing B, I'm seeing E, and this is O. And I'm seeing that this angle over here, this angle is 0.9. We are looking for this distance. This distance, which is, I can call it OE. But what is this distance? Well, the distance from here to there, that is going to be nothing but it's 6. So this is 6. So for me to find OE, I can definitely see that I have to use the cosine. Okay? Right. So the cosine, this is obviously a right angle triangle. 0.9 is half of 1.8. All right. This little c is a symbol for radians. So I will say the cosine of 0.9 is equal to OE, okay, which is the radius, over 6. And then this is given in radians, so make sure your calculator will be in radian mode. Now, OE, which is my radius, is going to be 6 times the cosine of 0.9. So let's see what that is. All right, calculate this in radian mode already. So 6 cos 0.9 and hit enter. Well, of course, I get 3.72. Let's just take a capture of that. This answer, if you round this answer to 3 significant figures, you will see that therefore the radius of that arc is 3.73 centimeters, correct to 3SF. All right, so you will have to do a lot of work from your diagram in order for you to be able to solve those questions. Now they want us to find the area of the shaded part. Right, the area of the shaded part. Now there is a lot of work involved here. I'm going to say, what is the area of an arc? So I'm just going to say area of an arc. We know that an area of an arc is a half the angle times r squared. This is in fact given in your formula sheet, but you should definitely know this as well, right? Let me just go clean up that diagram and take a picture of it and bring it here, okay? Or I can just as well bring it just the way it is. Let's hope that the software holds. Okay, let's take that. I'm going to put a diagram over here. Right, I have enough space. Just make sure that I have enough space to work. Good. So I'm going to do one thing. I'm going to find the area of the major arcs. I'm going to divide them into a few things. So I'm just going to write area of major arc, and this is major arc AB. This whole one, major arc AB, that is equal to, remember half is there, so I'm going to have a half. And what is the angle? Now here's the thing, this angle from here to here, the whole thing is 2 pi, so this is going to be 2 pi minus 1.8. That's what that angle is going to be. So it is 2 pi, which is the whole 360 degrees, if you look at it in terms of degrees, minus 1.8 radians. Okay, and what is the radius? The radius there is 6 squared. And if you punch this in, you're going to get 80 point. You're going to write as much values as possible, because I am not totally done with the question. All right, and that is square centimeter. So that is the biggest shaded part, major arc. Then I'm going to also then calculate the area of minor arc. That minor arc is CED, which is again a half, and it's the CED. You can see that? A half. And what is the angle? Well, we know from the angle, from what we had, it was 3.73 radians. And what is the radius? Well, we just calculated the radius. The angle, sorry, the radius, the angle there is 1.8. Okay, the radius was 3.73. So just write it nicely, don't get confused, using the formula. My angle is 1.8 radians, and that is the angle, and my radius from before was 3.73. Okay, squaring that. That was given to us, and that is what we proved also in the previous question. Good. Now let's just see what that is equal to. Well, when you punch this in, you're going to get 12.52161, obviously square centimeters. So now we can actually calculate the area of the shaded part just by adding those two. So area of shaded region, okay, it will be 80.697 all the way up there, 33553 plus 12.52161. All right, all of this, if you add them together, that's what we work with. Now you can obviously grab your calculator, but I've worked it out. So this is 93.2189, okay, 4 and so on centimeters square. And then we're going to give our answers to three significant figure, which is 93.2 square centimeters correct to 3SF, which is what we're going to follow if they did not specifically tell us in the question what degree of accuracy is it that we need to use. Okay. Right, so that takes care of that question. So we're going to have question 7, relative to the origin. You have the position vectors of OA and OB that are given to you. Now I like to write them from that form in in column vector form. So that is 3, that is 2, and that's -1. And the other one, OB, that is obviously going to be 4, -2, and 5. I like to write them like that. They say find vector AB. They're saying AB. All right, first we're going to find vector AB. From position vectors, you should know that vector AB is equal to vector OB, that's the position point of the second, minus the position point of the first. That's what you definitely have to know, okay? What do we have? We know what OB is, so we're just going to subtract corresponding elements from each other. So we just write it in proper order. So we have 4 minus 3, that is 1, -2 minus 2, that is -4, 5 minus -1, that is going to be 6. Okay, and this is, in all intents and purposes, this is AB. That's what we were supposed to calculate there. Or if you want to, you can also leave. You can also then give it in terms of its position vector or unit vectors. You can say AB is equal to I, that's 1I, minus 4J plus 6K. Okay, these ones are all unit vectors. All right, just like that, you can give it in any form that you wish, whether you give it in base vector form or you give it in column vector, it's still acceptable. Right. Then they say we need to find OC. Now, the important information is this one. They say the point C is such that, let's just bring it. I'm going to just put it somewhere here. The point C is such that AB, which is what we calculated, is equal to BC. Okay. So we need to find OC. Right. So if I have to say we start somewhere, so I start from here as a diagram. Let's say this is OA as a diagram, okay? And then we also were given OB, so we are going to have OB. So let's say OB starts from here. Let's say that is OB. Let's say I write, okay, there we go. Yeah, as I was saying, so this over here, this would be OB if I have to do that. And then what they are now saying, we are supposed to find OC. So let's suppose OC is somewhere over here. Okay, OC. So something else that we have, they said point C is such that A to B is equal to B to C. So the distance from here and the distance from there, they are equal to. All right. This distance is equal to the distance. Right, so what I'll then do, looking at this diagram, I'll say if you want to go from O to C, you can take the route, think of it as a route OA. So this is me going from O to C. That's OA plus AB, because since AB is equal to BC, that's all I need, okay? Right, from our work in the previous one, we know what AB is, and OA is 3, 2, and -1. OA, so it's 3, 2, -1. That is 3, 2. You just use it as it's 3, 2, -1. Let me just use column vectors, it doesn't really matter. 3, 2, -1, that is OA. And AB from our answer that we had, we have to multiply our answer 2 times because we have to go from A to B to C. So that will be plus twice AB. Okay, twice AB. And what is AB? From what we gathered in the first question or in the second part, it was 1, -4, and 6. 1, -4, and 6. Okay, so twice that. So we can actually multiply out that scalar. So we have 3, 2, -1. And then you have 2 times that is 2. Okay. And 2 times 4 is -8. And 2 times 6 is 12. All right, so let's just see what we have. We have OC is going to be 5. I'll just write it there. Unit vectors. 2 plus -8 is -6. And -1 plus 12, so that's going to be -11k. Right, it's totally up to you whether you want to leave your answer in terms of base vectors, unit vectors like so, or even leaving your answer as column vector is also acceptable. All right, so if you had 5 here, minus 6 here, and minus 11. This is also acceptable. All right. Now, they say calculate the magnitudes of OA and OB. So OA, what was OA again? So we just have to quickly go back and find OA. OA was 3, 2, negative 1. Oh, that's 3, 2, 3, 2. Just write it like this. 3, 3, 2, negative. See, I have to go back. 3, 2, OA is 3, 2, negative 1. There we go. Okay, and then what was 3, 2, negative 1? And its magnitude would be, using Pythagoras, it's 3 squared plus 2 squared plus negative 1 squared. And this answer is the square root of 14. And the other one is OB. And what was OB? OB, if we have to get it, OB was 4, negative 2, and 5. 4, negative 2, and 5. So it's square root of 4. It's 4i, negative 2j, positive 5k. Okay, that was OB. Then if you calculate its magnitude, then OB, the magnitude of AB would be 4 squared plus negative 2 squared plus 5 squared. Then we take the square root. In this particular case, I'm going to leave the answer in this form, square root of 45. Right, when they say find the scalar, first thing is what I need to find. Remember, they are looking for the angle between the vectors OA and OB. So O to A again, and O to B. This is the angle they are looking for. So you are looking at OA. I'm going to dot it with OB to see what is the dot product. Now, from what I calculate is I know that OA, so I'm just going to write 3, 2, negative 1. I'm going to dot that with OB, which was 4, negative 2, as well as 5. Okay, just to make sure that you have the correct answer. So we're looking for the scalar product first. So this is going to be 3 times 4 plus 2 times negative 2 plus negative 1 times 5. If you work this out, you're going to get 3. Now, the nice thing about that is that the angle, if the scalar product is a positive number, then the angle between, so cosine of that angle, so if I call this angle theta, that angle is going to be an acute angle the moment you have the scalar product as a positive number. Okay, and hopefully you are aware of how to calculate using the formula and so on. Okay, right, so angle OAB is equal to 83.1 degrees to 1 decimal place. Good. Right, let's look at question 8. You have to prove the identity. The identity is sine theta times tangent of theta all over 1 minus cosine of theta is identical to 1 plus 1 over cos theta. So I'm going to take the left-hand side. The left-hand side, this is sine theta. Then tan theta is nothing but sine theta over cos theta. Okay, and all of this, I can put this 1 over 1, no problem. All of this over 1 minus cos theta. All right, then if I obviously look at the numerator of that one over there, because you're multiplying, so the numerator there is sine square theta over cos theta. I'm just going to then write 1 divided by 1 minus cos theta, and it's just easier for me to do it like so. Then from the first Pythagorean square identity, or the basic one that you should know, you know that sine square theta plus cos square theta is identical to 1. Then sine square theta is then identical to the same as 1 minus cos square theta. So this one on top, I'm going to write it as 1 minus cos square theta, and that is all over cos theta. And that is going to be times, then right, 1 over 1 minus cos theta. Then what you have here, the numerator, is like the difference of two squares. All right, so this is 1 minus cos theta, and then 1 plus cos theta all over cos theta times 1 over 1 minus cos theta. Then you do realize that this and this one cancel, leaving you with 1 plus cos theta. Then I'll just rewrite that as 1 plus cos theta over cos theta, which I can write separately as 1 plus, or let's say 1 over cos theta plus cos theta over cos theta. And obviously, if you were to clean this up, this is going to give you 1 over cos theta plus 1, which is, if you look at it, you can rewrite this to match the right hand side as 1 plus. So this is the same then as 1 plus 1 over cos theta, which in all intents and purposes is equal to the right hand side. Okay, obviously you have to always look at, whenever you do these questions, to look at how the form is that you are supposed to give the answer to. Right, this could be regarded as just a side note. Okay, let's then look at part A. Now they say, hence, solve the equation. So what we need to do here is, since this side, this whole of this side is equal to, this whole of this side will equal to what we just were proving, that is basically 1 plus 1 plus 1 plus 1 plus 1 over cos theta plus 2, well, equal to 0. So we're going to look for that angle, whatever that angle will be between 0 and 360 degrees. So it is going to be the same as 1 over cos theta plus 3 equals to 0, which in turn becomes 1 over cos theta equals to negative 3 over 1. Ultimately, you can then write it as cos theta is equal to, switch that around, 1 over 3. Okay, then we can find the basic angle or the reference angle, which is the inverse of, leave that as a positive value. And since the domain is given in degrees, you must make sure that your calculator is in degrees mode. So just change that, if it's not changed, to degrees. And we're going to calculate the inverse cosine of 1 upon 3. And this is my reference angle. which is 70.5. So this is the reference angle. And we know that cosine is negative in the second quadrant as well as in the fourth quadrant. So if you look at it, you'll be saying that in the second quadrant, the angle theta is going to be 180 degrees minus 70.528 and so on degrees. That will be in the second quadrant. And then in the third quadrant, all right, theta will be 180 plus 70.528 and so on degrees. At the end of the day, if you do the final calculation, theta is going to equal to 109.4 degrees and theta will be 250.5 degrees, okay, respectively. Okay, so the only thing that you needed to all take in consideration is that this is identical to the part that I highlighted in the first instance, and then you work your magic from there. Okay, that brings me to question. Question 9. Question 9. Find the possible values of x correct to 2 decimal places for which arcsine is x squared minus 2 is equal to 2 pi over 3 radians. All right. So what you're dealing with here, you're dealing with inverse of trig functions. Then the inverse of trig functions mean that in order for me to find whatever this is just going to be sine and then 2 pi over 3, it's like we're switching that, is then going to equal to x squared minus 2. It's like you are switching that. Right. So we can actually calculate this using our calculator, but since the angle is in radian mode, okay, if you don't know the special angle, then I suggest you changed from degree to radian, and then this is the sine of 2 pi over 3. What is that value? Well, that is root 3 over 2. Okay, so this is root 3 over 2, and this is equal to x squared minus 2. Right, so this becomes the equation, and an equation in x that we are going to find to 2 decimal places, because you know you can already see you're dealing with some sort of irrational number over there. So it gives us that x squared is going to equal to root 3 over 2 plus 2. Okay, now what the answer of that is, x is going to equal to the square root of all of that. It's going to be the square root, the positive and negative square root of this business here, root 3 over 2 plus 2. Okay, so let's see again using the calculator. We take the square root, and then we have got root 3 over 2 plus 2. Right, so we do get an answer of 1.69. So to 2 decimal places, I'm going to have 2 possible answers, one being positive and the other one being negative. So I'll just go ahead and write x is equal to positive and negative 1.69. Right, and that is the acceptable answer in this part. Okay, good. Right, so that is question 9, and we are now ready to do question 10. A ball is projected vertically upwards from ground level with a velocity of 80 meters per second. The velocity is 80 meters per second. Then they also give us that the height is given above the ground is given as 80t minus 16t squared. Then once they tell you to find maximum height, what this maximum height means, this here implies that the height dh dt is equal to 0. So we definitely need to come up with differentiation. Okay, what is it that we need to consider? Now, to find dh dt equals to 0, then what is dh dt? dh dt, since we have the formula here, h is equal to that, we can actually go ahead and differentiate dh dt. Differentiating dh dt, this is going to give me 80, the derivative of 80t is just 80, minus 2 times 16, which is 32t. Always take away 1 from the power. We are told that this is equal to 0. This is going to allow us to find the time, because we are looking to calculate the time it will take. So this is minus 32t is equal to minus 80, and then at the end of the day, t is equal to t will be equal to 80 divided by 32. You take note, a negative and a negative is going to give you a positive answer, which is 2.5 seconds. All right, and this is part A of the question. Okay, then part B, find the maximum height reached by the ball. So very straightforward. What is the formula for the height? The formula for the height, remember, was 80t minus 16t squared. So the maximum height, you just substitute, right? The maximum height, we just substitute where we have a t, we substitute our time, which is obviously 2.5 and 2.5. Right. Once you do that, you're going to get that the maximum height is 100 meters. Okay, so that is just substituting in there into the formula. Right, then we are going to question 11. They are saying, given that f of x is equal to 9 all over, so f of x, I'm just going to rewrite it as 9 times 3 minus 2x raised to the negative a half power. That's what I'm going to write it as. And then we have to find the first derivative and the second derivative. Right, so the first derivative, we are going to use the chain rule as it is, and I hope you know that the chain rule. So first of all, what we have is we are going to have this 9, we're going to multiply that by negative a half, and we keep the 3 minus 2x, so the power here decreases by 1. So negative 1 over 2 minus 1, that's negative 3 over 2, and then we multiply that by the derivative of the inside, which is just going to be negative 2. Okay, right, so let's just clean this up. Of course, you have this a half, negative a half times this 2 sort of cancelling, leaving you with 9, and then you have 3 minus 2x raised to the power of negative 3 over 2. Okay, I can leave it like that, or you can go ahead and say, or this is the same as 9 over the square root of 3 minus 2x raised to the power of 3. Okay, so if I have to find the second derivative, then I will take the second derivative. So I'll rather use this one over here. Then again, it's 9 times negative 3 over 2 multiplied by the same thing remaining, and I'm going to take 1 away from that. that is 2 plus 3, that's negative 5 halves. And you're going to multiply that with the derivative of the inside again, which is negative 2. Okay? Then you will definitely see that if you multiply negative 3 over 2 times negative 2, that's just going to leave you with 9 times 3. And then you have 3 minus 2x raised to the power negative 5 over 2. So let's clean this up. This is going to be 27. This is 27. Then it's 3 minus 2x raised to the power of negative 5 over 2. Or you can therefore leave it as 27 all over, okay, all over, you have the square root of 3 minus 2x, and it should be raised to the power of 5. So these are your two possibilities, right? Your answer, that's the second derivative, and the other one over here, that's your first derivative. Okay, that one is your first derivative. Okay, right, that brings me to question 12. So you have a diagram that shows that region R is bounded by a curve and the y-axis, all right? And then you are told, given the t, so this is an improper integral, and given as shown, we are supposed to show that as t tends to infinity, the area of the region tends towards a finite value, and we need to determine what that finite value is. Right, since this is an improper integral, there are many ways you can do this, but I would suggest that you would be substituting, keep t as a number as you would integrate from 2 to t, normally definite integrals, obviously of the function 18 over 3x plus 2 all squared, okay, with respect to x, right, as you would integrate normally. And then towards the end, we know that the limit as t, there is a limit, the limit exists as t tends to infinity. So I'm always going to keep that in mind, but I'm just going to do that towards the end, okay? So this is therefore going to be, I can just rewrite this as the function as 18, and then I have 3x plus 2 raised to the negative 2 power. This is obviously integrated with respect to x. Right. Now, hopefully, you also recall from your rules how do you integrate these types where you have ax plus b raised to the n with respect to x types. And the way you integrate that is you take 1 over a, and then obviously by adding that new power that you are going to have, so let's just maybe put that 1 nicely, right? Then you multiply that with ax plus b, whatever that one n plus 1 is, plus the constant of integration. So I'm just going to use that also here. So integrating that would give me, that negative 2, so that's 18. Okay, so that's going to be negative 18, right, times 1 over 3. That's 1 over 3. Okay, very important that you do take note of it. All right, so I'm going to add 1 there. So that's what I did there. If you add 1, you're going to get negative 1 times that is negative 18 all over 3. So that negative that you are seeing is the new power. Because if you add 1 here, if you add 1 to negative 2, you get negative 1. Divide that by the new power. That is why there is negative 18. All right. Then you are going to obviously say times, in bracket you can do that, of 3x minus, or plus 2 rather, Now that's raised to -1 power, new power there. All right, and we are going to integrate from 2 up to t. Now before I do anything substituting my limits, I must just quickly just clean this up over here. It's totally up to you, but I just believe that it looks a little bit better if we could just clean this up. So this is -6 over here. Okay, that is going to be -6, and then I have in bracket I have 3x plus 2. All right, perhaps you can also, if you decide, we can also write that as a fraction, which will make it a little bit much easier. Okay, so it is going to be -6 all over 3x plus 2. That's what that business is, and we're going to substitute in now our limits. Right, starting with our upper limit of integration, our upper limit integration, that is going to be -6, and then it's going to be 3t plus 2, right? And then we're going to say minus the same thing, -6 over 3 times 2, lower limit, plus 2. Right. Now, there is obviously a consideration. So what does this give me? This is -6 over 3t plus 2. And this over here becomes a positive. And if you work it out, it's going to be +6 over 8. Now, S t tends to infinity, okay, this first fraction, -6 over 3t plus 2, as t becomes much bigger and bigger in the denominator, when you divide by a very bigger and bigger number, the number tends to 0 in this case. Okay, so the finite area then, is going to be this 0 plus 6 over 8, which is basically the same as 3/4, all right? And that is going to be 3/4 square units. That is what we are looking for in this particular question. Good. That brings me to question 13. A cylindrical tin of paint has a base radius of r, as you can see, a perpendicular height of h. The tin has a capacity of 2000 pi cubic centimeters. Okay, just maybe to explain the concept that you have capacity and how it relates to volume. Right, so 1000 cubic centimeters is the same as 1000 milliliters. Okay, so you shouldn't get thrown back by that as I'm now working with volume. Right, so if I work with volume, then the volume of this cylinder is going to be pi r squared, the cross section, times the height. Okay, we need to show that the area, the area of it is given by 2 pi r squared plus 4000 pi upon r. Now, so I'm going to definitely compare the volume, since everything is cubic centimeter, which is the same as milliliter. Okay, so there shouldn't be any problems for you to consider what the volume here is. So the volume, which is pi r square h, is equal to 2000 pi. Okay, now I need this formula in order for me to find the value of h in terms of r. So h is going to be 2000 pi divided by pi r squared. Then you are going to have a scenario where the pi's cancel, leaving you with the volume of the height, leaving you with the height of 2000 upon r squared. Now that we know what the height is, we can look at what is the total surface area. So the total surface area of this cylinder, you're going to have 2 pi r squared. That comes from, it's a tin of paint, so it's closed. So I'm now looking at the area on top, which is a circle, so that is one circle on top. So, and then we're also going to look at the area at the bottom. The area at the bottom, that is also going to be another circle, because we're looking at the total surface area. So it's the area of two circles, which is the same as 2 times the formula for the area of a circle. That's why I have pi r squared there. Then we have the curved surface part. Now, let's see. Hopefully that the software is not acting up, because I just want to grab that part there for explanation purposes, right? Or let's not do that. Let's just work from here. So this part that I am now highlighting, right, that goes around. So that is called the curved surface of the tin of paint. That's the curved surface. Now, if you look at that curved surface, there is a way that you can calculate it. Curved surface is like you calculate. I'm just going to stop somewhere there. All right. So it goes all around. So at the end of the day, the curved surface area of a cylinder, it's, if you look at it, it's like the circumference times the height. Is the circumference times the height. If you cut it open, it forms a perfect rectangle. So it's the circumference, which is 2 pi r times the height. This is how you calculate the curved surface area. Right. What do we know? We know from our answer before that the height is given as 2000 r squared. That's what we have from there. So we just have to clean it up basically, and then this still remains 2 pi r squared over here, plus, now obviously the r's, they will cancel, and then the numerator times that is 2000 times that, times 2, that is 4000 pi, and it will still be over r. And surely this is what we needed to prove from our answer. Just go back and you will see 2 pi r squared, 2 pi r squared plus 4000 pi over r. That is the answer for 2 marks. So it is knowledge of, like, work that you have done at ordinary level that you are now applying here. We haven't yet did any type of calculus in any type of way. Right. Then they say to minimize the cost. When you come across words like minimization, you will definitely deal with a derivative. Okay. The manufacturer of the paint wants to use the minimum amount of sheet metal for the tins. Right. Then, given that R can vary, find the value of R and H for which the surface area is the minimum. So the area, we know, the area is 2 pi R squared plus 4000 pi over R. So when the area is the minimum, that is dA, dr should equal to 0. That's first. Okay. Then they also then say we are supposed to find the value of R and H. They do not ask us to calculate the area. Am I right? Then they say, in terms of pi. And also we have to find the minimum surface area. So we need to find 3 things. We find R, we find H, and we are going to find the minimum area. Okay? Very important. So your keyword lies here. Find R, find H, and find in terms of pi the minimum surface area. So there are 3 things here that we need to find. So let's first differentiate what this is. So we are going to say dA dr is equal to 4 pi r. Then this can be written maybe before I write this stuff here. Let me just rewrite what this area formula can be written as, because I don't like this fraction. This can be written as A equals to 2 pi r squared plus, you have got, very important now, you have got, is it plus, right, you have got, taking that r over, you will have in the lookout for that, you would have 4,000 pi r negative 1. I think that makes perfect sense if we have it like that. Okay, good. Now I can actually differentiate. Makes it much easier to differentiate. So therefore, dA dr is going to be 4 pi r with me, and the negative times that is going to be negative 4,000 pi, and then you have r to the negative 2. Take away 1 from there. Okay, so this I can now rewrite as 4 pi r minus 4,000 pi over r squared. And I know that it should equal to 0. That's why I want to do that. Now, how do I solve this? First, you can multiply throughout by r squared. That means you multiply this term by r squared, you multiply this term by r squared, and you will multiply here by r squared as well. These will cancel. This is going to leave you with 4 pi r cubed now. Then you have 4,000 pi, and then you have obviously 0, because 0 times anything is just 0. Okay, once you're here, remember we are trying to find the value of r here. Okay, so for me to find the value of r, I will then factor out my r. Okay, or not the r, rather I will just, let me see what I can factor out, make it much easier. I can take out 4 pi, because 4 pi goes in both of them. This is going to leave me here with r cubed minus 1,000, okay, is equal to 0. Then the equation becomes 4 pi is equal to 0. There's nothing there to see. I am interested in r cubed minus 1,000 is equal to 0. So from here, I will see that r cubed is equal to 1,000, and 1,000 is the same. If you take the cube root, it will be 10. So my value of r then, my r value is 10. R is 10. Now, what is h? So from the work before, we know that h was equal to 2,000 over r squared. Okay, just make sure that you still remember that. That is h here. Here we go, 2,000 over r squared. So I now know what my r is, so therefore my h value will be 2,000 over 10 squared, which makes this as 2,000 divided by 100, which is just 20 centimeters. So now I have my value of h, and h is equal to 20 centimeters. Okay? So now I can find my area. My area, remember, the area formula was 2 pi r squared plus 4,000 pi over, what is it, over r. Just to make sure that you have that from before. The area was 2 pi r squared plus 4,000 pi over r. So 4,000 pi over r. So now that I know what my r value is, I can actually calculate the area. So that is 2 pi times r, which is 10 squared, plus 4,000 pi upon 10. Now they say you must leave your area in terms of pi. If you do that, this is 100 times 2, that is 200, oopsie daisy. This one here is 200 pi, and then plus 10 into that, that is 400 pi. At the end of the day, the answer is 600 pi. And since this is area, it becomes 600 pi square meters. Okay, so this is our final answer with regard to the area. So we have answered all three scenarios. They ask us to find the area. Yes, we did. And they say we must leave the area in terms of pi. Yes, we did. They ask us to find the height, and the height is 20 centimeters. Then they also ask us to find the radius. So it's very important that you read these questions and see what you need to do. They said you do not need to prove that the area is a minimum. They already told you the area is a minimum. Therefore, that is why we have dA dr is equal to 0. Okay. Right, so that brings me to the end of this paper for 2023. Please make sure I see that 70% of you who watch the videos, who download them, are not subscribed to the channel. So we need to get the algorithm to work in our favor. The more you subscribe, the more content I upload.